able to see your comments. Ben, so maybe do you want to just give everybody a brief explanation of what you've been working on?
Yeah, so with the setup that I have now, and I got it ready to show you guys. Unfortunately, I blew the fuse in my one new multimeter, so I won't be able to show you the current on it. But if you can take my word for it, the current is being maintained on both ends. And I've double checked, I've triple checked everything. There's really no way that you can set up the multimeters to be inaccurate at this point, because channel A and channel B aren't even connected, right? They're sitting on top of each other in a bundle, but they're not actually connected.
Yeah, they're isolated.
Right. So, I mean, you know, there's still some part of the back of my brain saying, you know, like, I got to be missing something, or I'm not understanding something, but all the numbers seem to be checking out. The coil's doing exactly what everybody says it does. And I just can't believe that this isn't like all over the fucking news.
Yeah.
Yeah. If you've got if you've got something set up, we can put you on. If you want to do a show your setup, Ben, I can highlight your screen if you want.
Yeah. Let me disconnect a couple of.
So Ben, what is that? A POE? Oh, we lost your audio.
Oh, Ben, we lost your audio. We can't hear you. Uh-oh. Well.
We lost your audio. Yep, that's better.
Back.
Sorry, I had to the studio.
Oh, nice.
Can you see that?
Yeah, so that
is
is
turn my
POE?
laptop.
Yeah, it looks like a POE.
Yeah, it's a POE coil based off of the design of Erica and Daniel Nunez of First Stop Energies. And it's all color coordinated, so you can see the channels here. Channel A is red in, out is black. Channel B is yellow and green. And that's going to like a custom circuit that I have with a little rectifier and a DC motor. And it's also got a couple of 3 LED lights. So it's powering a load while it's doing this. It's doing actual work.
Right.
That's awesome.
And
I see you got a metal ball.
Here,
that's amazing.
Yeah, at 3 kilohertz, I was getting about 3.5 volts on the input, 0.15 amps on the input, and on the output, I was getting 6.1 volts and 0.2 amps on the output. That's 113% gain.
There you go.
Right? I mean, it's tiny increments. It's you know, like, but it's a proof of concept that this stuff works.
Yeah, over unity is fact.
Right, and nature does it all the time. So to discredit that is kind of ridiculous. But I have the neodymium sphere set up. I'm going to show you the low end frequency.
Yeah, I want to see it spin. Is it going to spin or?
Yeah, it's going to spin like not. Here we go. Oh, look at that. We're at 4 hertz right now. I haven't even touched it. And again, I forget his name, but like he said, it could be running and running and running, and it won't get hot.
Yeah, yeah.
Like that?
We can't see it. Try it again. Oh yeah, see. Right. Yeah, so you got a spinning field there. Yep.
Yeah, so that's 4 hertz, and if I take out my magnetic pull detector, we can see if we can detect a pull, but I wasn't able to detect one except that very high gain.
Yeah, that's the 0 point. It's just following the field going in a circle.
Right.
If you put more voltage and more current, that ball should be spinning around and around and around.
Right. Yeah, the correct frequency and input.
Yeah.
Here's 5 hertz. It's going a little bit faster.
Yeah. Yeah, if you speed it up even faster, it should go all the way around.
Right. Yeah. See, it wants to synchronize. See, it's wanting to synchronize with the field, but I haven't achieved it quite yet.
Now, I've seen somebody do a similar experiment with that. Hold the magnetic ball in a cup about 2 feet away, and it's still spinning.
When you capture the magnetic moment, you've reached magnetic synchronicity, and you can do that. You can get it synchronized with the vortex field, and then take it outside like 15 feet, and you'll still affect it.
And it will still affect it, yeah.
Yep, and you can even power down the coil, and you can see it still affecting it for a little bit of time. Because the coil, it kind of stores energy. That's what it seems like.
Cool.
And now let's bust out the tone generator. We got a tone generator here. I'm gonna put it on 800. Oh, that's a little bit too fast. Yeah, baby.
It almost flew off the table.
Yeah. Every step of the way, this coil has surprised me.
Testing 1 2.
And we're getting 3.6 volts on the output. Let's take a look at the input.
Try slowing down the pulse rate.
2.3 volts on the input. Can you see that?
Take off the light on it.
Oh, take off the light?
Yeah, take off the light. Yeah, now we can see it.
2.350 on the input. That's voltage.
Yeah.
And you got 3.638 on the output.
Yep, there you go.
Yep. And it's powering a load. And I wanted to make sure it's, I wanted to see how it would affect the DC and the AC at the same time. So, I kind of split the circuit a little bit, but it didn't seem to affect it at all.
That's
So
awesome, man.
So
Right?
you can power
This is epic
motor
work,
and
Ben.
power a light.
Yeah.
I like the duct tape.
Yeah. But I did notice that without the capacitor, it kind of stops and you have to re-jump it. So the signal's kind of jumpy.
Yeah, you have to give it some capacitance. It doesn't have enough capacitance in the coil to drive it. So yeah, a capacitor definitely will help.
It's incredible. Like this coil, and it wasn't that hard to do. It took some time, but I think almost any engineer could whip up one of these.
Yeah.
Is that the rodent coil?
It's
Yeah.
the
I'm
POE
gonna be
similar to
putting.
the rodent coil.
Yeah, it's
By the
based
new
on
guy.
Rodin's math, but it's
So I'm going to be putting out a comprehensive text guide this weekend, and then a
Yeah, but
demo
doesn't-
video to go along with it.
That's
isn't
awesome.
Daniel Nunes' work based on the Rodin coil?
Yes. So
Yeah, okay.
Daniel and Erica Nunes of First Stop Energies was they pretty much perfected this coil, and they were open sourcing it. But their mistake was they tried to patent it, and ever since then they kind of went off the circuit. I haven't heard from them.
Right?
I
He
haven't
deleted all their videos
been able to
and
find any
stuff.
information on them.
Yeah, like literally
Yeah, all their videos
their
were taken down off of
got taken
YouTube,
down.
and I know
Yeah.
they were taken down off of YouTube.
The patent means that it's not open source. If it's got patent, it's not open source.
Well, they were.
No,
thought
they
I heard-
patented a version of it, but they were showing people how to set this up.
Yep.
They were selling kits, is what they were doing.
Yeah.
But they had a version of this coil that was patented. You can go online; the patent's still pending. It's not
Yeah.
called the POE
Somebody-
coil. I can send you the link, but
Yeah,
it's got some
please do.
weird name, but it's basically the same design.
Didn't somebody take them to court, like to
Yeah,
shut
they're
them down? Personal, like,
Yeah, I
maybe-
wouldn't doubt it. I wouldn't doubt it.
that's
that
what they
usually
do.
happens when you find something, if you know what I mean.
Yeah, they'll go after you financially. They'll tie you up
Yep.
in court, and they'll basically try to bankrupt you. Is what they're going to do.
Right.
That's
And
part
that's
of-
why I'm not interested in
that-
making money. I just want to study
Yeah,
it. I just want to
gotta
study the
open
science
source.
and maybe have people
Yeah.
replicate this.
100%.
I'm so broke,
Good
ain't
on
got two
you,
nickels
Ben.
to rub together.
Open
So let them
source.
come after me. I don't care.
So I'm gonna run this
Haven't
coil a
got a
little
pot
bit,
to
and then
piss.
we're gonna do it temperature test. If that's
Yeah,
cool.
absolutely.
Yeah,
Yes,
do
please.
that.
I'll highlight you
Yeah,
on
I want to see what's
screen.
happening in the
This
middle of that
is
coil.
amazing stuff. I'm stoked. Like I've been trying to
Even if
find
it's a few
anything
degrees,
on
that shows
Bermuda's.
up because you're only
Well,
because you're only using like 2.3 volts, right? You're not using much voltage, so you might get
Yeah.
a degree or two changing. But if you got it up over 25 volts going in, you might see some more dramatic temperature changes, right?
yeah,
So
I'd like
try to step it up.
pump
Don't
to a
don't be afraid.
Well, the
Yeah,
thing is
don't
with
be
this
afraid.
stereo receiver, it's an old stereo receiver, so I think it's shutting off because the energy coming back in is just too much for it. Like it's multiplying the energy
It's
going
like
and then coming back and shutting it down if I go too high on the gain.
yeah, it's feeding back. It's a feedback.
You need
It's
to
like a
use
feedback
resistors.
loop.
Yeah, you need to use resistors on your feedback, like your ground from your POE back to
Okay.
your stereo. If you use resistors, those resistors are going to heat up, but you'll be able to sustain your output.
Oh, that's a good idea. Yeah, I could try that for the next version of the system.
Yeah. Make sure you keep those resistors cold because they could melt.
Heat.
Yeah,
Yep.
What
but it depends how
ohms are
much
we
power
talking
he's putting
about?
through it, right? Like he's not putting too much. Like an amp's not. It's not going to melt. Well,
No,
then again,
I'm saying if he's going in higher potentials, like if he's hitting
Right.
like
And are we
25
looking at
volts or
the
that's
whatever.
what I mean. You never know, right? You get that surge from an output on a POE, it could melt some shit. You never know.
Yeah.
If you're pulsing, you can control
Right.
the heat with your pulse rate.
Yeah, to a point. Yeah. It all depends on the
Low
what
frequency.
do you call it? The resistance
frequency.
in the coil. You know, have you tested how many ohms resistance that coil is?
So actually I haven't looked at the resistance yet.
Looking
But
at it,
it's going to
100
be
ohms.
less efficient than the Nunez design, specifically because I screwed up the bundle. When you're bundling the wire, you want it to be uniform. And unfortunately, I didn't tighten it enough when I was twisting the wires together. So there's a couple of spaces where the wires kind of like jump up a little bit and aren't packed together. So that I suspect is affecting the system in some way.
100%. Bob
when
Grenier
Daniel Nunez-
states with like the exact same thing with his windings as Keshi and the Magrav, all of them, that you have to have that same consistency throughout in the spin to maintain the field unity of the geometrics of it.
Yeah,
Right.
that feel unity is because of the skin effect. Each additional line actually multiplies the one after it. That's why you have to get it really tight.
Right. So they have to be like compacted.
Yeah.
No, that all makes sense because you're taking two counter-rotating magnetic fields and you're compressing them on top of each other in such a way that you create that singularity.
Yeah, and you have to follow it to their uniform path. Otherwise, it doesn't quite work well.
Right. And there's specifically a more advanced version of the POE coil before they went silent. And what they did was basically they just made the openings on the coil frame very thin, V-shaped, so that you can only fit one wire at a time, but you're fitting them on top of each other so they're perfectly symmetrically in a line, right? And that they claimed that version was so advanced,
cancel out.
right, that it didn't produce any O3, which is a common
It
problem.
cancels out. You get identical signals cancel each other.
Right, exactly.
You have to have different flow rates of current as well.
Mm-hmm. And I'm also seeing that because you don't really get to know and understand these systems until you work with them. Theory can only bring you so far. But I'm starting to see that the rodent coil has multiple resonant frequencies. There's one on the lower end and one on the higher end. And on the lower end, it has a strong electromagnetic field, and on the higher end, it seems to produce tiny amounts of overunity, at least in my system.
Yeah, start playing with higher voltages.
I do have because they do recommend a HV capacitor. I'm not sure if my coil is
high
efficient,
voltage.
but yeah, it's supposed to output high voltage, and it does this. The secret to their design is the method that they use is an open circuit system.
Yeah.
Where
open
they
loop.
use an open loop, and I guess it leaves room for it to resonate more in the cavity.
Yeah.
Well, the open part is when the transistor's gate is open. That's the open part of the pulse. So you have a pulse. There's an on and an off. During the off portion of this loop is the portion they're calling the open part.
Right.
That's when it's off.
So is it not
portion is when the flyback occurs.
Because it is being closed by the load.
When you close the gate, you create a load. The coil is the load.
Yeah, but
When you close the gate, you're connecting
I
the
see,
other
okay.
end of the battery to the coil,
Mike, this is the
and you're
difference.
charging it.
You're
That
talking
makes sense.
conventional systems, though. The POE and systems that me and
It's a pulse. It's a
Burn-
pulse system, right? That you're using here.
Yeah, I'm
The
pulsing it
pulsing-
with AC.
So there's an on and off. During the off, the coil inverts its polarity.
understood, but they're dynamic systems. They're not just one coil, one transistor. Do you know what I mean? They work
Yeah,
as
yeah. They're two. They're bifilar. I know. One
Yeah.
direction, one back the other. I get back the other way. I get you.
So you're
how
saying
did you
you're
phrase
using-
that again, Benefactor? Two fields in and how did you just said the specified you described
Oh, two
very
counter-rotating
accurately.
magnetic fields compressed.
Right. There you go.
Yeah.
Two counter-rotating magnetic fields. That's exactly right.
that's the pinch.
Right, and it's the secret is when you combine the resonance with the geometry, and that's, you know, if you look at the Tesla coil, he had the resonance right on that coil to maximize the voltage, but he wasn't choosing the path of least resistance for his coils. So when you
Absolutely.
combine the two, I believe you can achieve over unity.
I think
with
that
a third,
Tesla
with a third
was,
coil, maybe.
I think Tesla was using a path of least resistance, but he kept it hidden from the public.
Yeah,
Because his
that's
patents,
very
if you
true.
look at his patents, they were inverted and they were upside down. So that
That's
Really,
right.
I didn't know that.
Yep.
yeah,
Yep, they were
like
upside
his
down.
Tesla coil is actually a receiver.
Wow.
You reverse it, right? If you use the,
Okay.
the secondary as a primary, you can actually step down the power, and it's
That's right.
very interesting. Tesla.
Yeah, and when you see, because that
Right.
explains why he used high voltage when it went to the second coil, because it's in harmonic resonance with the first Tesla coil. It's going to harmonically resonate at the same frequency and the same voltage. So the primary coil, which is usually what triggers the secondary, he now made that into the step down transformer. So
Absolutely, and then there's a
And-
spark gap in there for regulating the
Right.
frequency
Go grab my
and everything.
thermometer.
He made the secondary was a step down.
yes, it was.
Yeah,
Yep.
when you reverse
He's-
it.
That's
Yep.
hard to believe.
No, not at all. It's a transformer, Mike. It's
Oh
just
wait, he was stepping down. What was he stepping down? Super high
Okay.
voltage?
yeah. So okay, you got
then I get
the,
it,
you
I
have
get
to
it now. I get it, I get it, I get it.
listen. You got the first Tesla coil. That's your transmitter. Okay.
Yeah, no, I
Or
get it now. You're
conventional.
stepping down super high voltage into the secondary. Then
Right.
he goes into the primary.
Okay. So my question to you is this: what happens when you step down from a high voltage to a low voltage?
You gain
What
in
happens?
amps. You convert voltage to amps.
Exactly.
You don't lose
Exactly.
anything. You convert everything. Nothing is
That's
lost.
right. Now you're
Unless there's
creating
heat.
horsepower. Now you're creating
Unless there's heat.
horsepower. Now you're creating horsepower with the second coil. It's not physically connected to the first coil. So therefore there's no draw off the first coil. It's just doing its
Okay.
thing. Right?
So what you're
That-
saying now is
First-
actually one of the secrets to the Wardenclyffe Tower. Now think about that, because
Yep.
radio frequencies are only voltage. There's no current. So
That's
if you
right.
could literally
Well, that all
collect the
depends
radio
on the duty
frequency-
cycle of the radio frequency.
If you could
That all
collect the
depends
radio
on-
frequency on the secondary of a Tesla coil and step it down through the primary, just like
Yeah.
Mike was describing, you now have a free energy system through the radio.
There you
wave.
go. Well, way over unity.
Right. Gerald, by the way, radio frequencies don't have much current because their duty cycle is very narrow.
They don't need it. You just need to collect that voltage
Right, they
and
don't
send
need
to
it.
the
They just need
ground.
the pulses for the sound wave.
Yeah, and when you send it to the ground, you literally collect it as it's flowing through to the ground.
But that doesn't mean you can't send radio signals with a wider duty cycle and transmit amps.
Yeah, true.
You don't
you
need
don't
to.
need to.
You well that yeah, you don't need to, because as soon as you're stepping it down, that's where your gains happen. You know,
Yeah, better.
True.
Yeah.
If you're collecting high frequency, high voltage radio signals and stepping it down to a low voltage
And
huge
the low
signal,
current.
then right.
You
and
got
the
Yeah,
current
because
goes
that
up.
spark gap is what regulates
Right.
the frequency, right? So-
Exactly, Mike.
Yeah, the ohms
That's
is
right.
doing something real crazy. Look at that. I put it on the ohm setting.
You could have an intermittent short, or I don't know if your
Is your
transistors
device on. If your device is on, shut it off. Just do it with just with the meter. Yeah, shut your coil off.
The only way to measure the resistance of the coil benefactor is you have to have it disconnected from the circuit.
Yeah, I
that's
see.
right.
Okay, there we
disconnect the. Okay, so you got what is 3.7.
At least one end has to be disconnected from the circuit. Then you can measure.
Was that?
I'm a layman still, so.
It's 3.7 ohms, right?
Yeah, 3.7.
That's low.
All learning live.
What is that? 18 gauge or 15
Yeah,
gauge?
So
that's good. You have
great. I love having this. I love having you guys here to help me and explain some of the things that I'm seeing.
So 3.7 ohms. 3.7 ohms. That means you have very little resistance in that coil. That's a good thing.
But enough to create a draw, enough to create flow.
That's cool.
Yeah, as long as you have a little bit of resistance in there or inductance, right? You can increase the inductance by actually putting a metal core in the middle of the donut, but you don't want that. You want to create that 0 point in the middle.
Right.
So even though that your ohms resistance of the coil is low, as long as you got a bit there, it's going to draw current into the system.
Oh, so you're saying
there will be
a little bit of resistance is necessary for that energy to transfer?
Sure. Yes. To a point.
To a point.
Now you could go.
Well, let's say you got 5 ohms and 100. And what is your voltage? 12 volts? 14?
It was
no,
like
he's
3 point something on the output.
He's using
no, what's your
voltage.
source? What are you feeding it?
Oh yeah, the source is a stereo at receiver. It was reading, I think, 1.6 going in.
Volts?
Yeah.
Yeah. Yeah, he's using low voltage.
So Ohm's law is V over I times R. I is your current, R is your resistance. And if your resistance is 3 ohms and your volts is 1.5, 1.5 divided by 3 ohms will give you your current. Hold on.
Got a calculator?
It's 500 milliamps. That's half an amp.
So half an amp going through it.
1.5 divided by 3 ohms.
Yeah. So you got a half amp current going through that coil.
But hold on. Don't think that's watts. That's amps. So
that's amps.
Half an amp. Yeah, 0.5 times volts. Volts times amps is your watts.
Yeah.
Times 1.5.
How many? 6 volts output? You said.
Oh yeah. What's your 0.5? What's your
output? It was 1.6 on the input and 3. It was like 3.
Okay, so
3.6. That is already.
How many feet in that coil do you know?
1.8 watts is your output, and your input wattage is volts times amps is 1.5 times 0.5. It's 0.75 watts. Less the 3/4 of a watt is your input, and you're getting 2.5 times that out.
That seems consistent with what I was reading when the actual multimeter was reading the current. Yeah.
So
and it's consistently 1-to-2 ratio on the voltage. I haven't really been able to break that except for as you tune it.
You're getting just. It's not enough to run itself. But if you
exactly. Yeah.
If you had more than twice, it would run itself, and then you'd have that extra for free.
So do you know how long your coil is? Like how many feet?
So when I wound it, I stretched it out to 50 feet, and I, did the winds 24 times for 24 wires. But it didn't actually use that much. I had a lot left over, so I'm guessing maybe 30 feet, 35 feet.
Okay. Do you think you can scale it up by changing some parameters of do you think if you enlarge it or use stronger magnets or whatever, do you think you can have it 3 times more power or something like that?
He can increase his output if he finds a better location where the signal is more in tune with his device, like somewhere else on the planet, where there's a different resonance going on with the device.
It's
if you walk it around a little bit and see what happens.
I think size has something to do with it, but I think it mostly is how many times you wind it around the coil, because different winds supposedly have different effects. You can take
grounded?
I'm sorry.
Is it earth grounded somehow?
No, I don't have it grounded to the earth. I'm in an apartment.
That would be the first thing I'd do.
You
And,
could even you could even ground it to your stove.
Oh,
Stove
yeah?
has the British. Yeah.
So
Right to the-
like checking the polarity, the side that you want to ground it to. Try to find out what the polarity is of that end that you're going to give it ground, and then give it a diode that is in fashion with that polarity.
Oh, to force it through that direction.
Yeah, or vice versa,
Or vice
depending
versa.
on what you're trying to do.
Right.
Yeah,
said
because
that's a good.
if it works, man, if it works well, I'll be your first.
Because otherwise,
customer.
whatever's going on, it's going to go back and forth. You're not going to have it going one direction, and that's not what you want. You want it to go into your battery, not back into the ground.
Right.
So I
I think
got
with
a question.
my first setup, I had a feedback loop where it wasn't actually outputting any usable energy, but it was registering, a high voltage output.
You said you had two resonant frequencies, one lower, one higher. Was one of your frequencies 157.5 hertz?
157.5.
Or somewhere around there?
So
what happened, G? That hurts. Tell me.
So
did your foot twitch?
Anything
No,
beyond
it's because the length of his coil in comparison to his ohms.
anything between like 600 hertz to 3 kilohertz is kind of the range at where you see the over unity effect, but it's really tunes in like closer to 1 kilohertz. It's almost like 800 hertz, I think, is the highest we got, 124%.
Awesome.
Yeah,
because the faster your frequency is, the more you're sending through the device.
Right, but too fast, it just takes a dump, and you see it like it just flattens out on the output, and you get less output, which is what you're supposed to get according to conventional science.
So every device has a certain amount of current it can deal with before it's not running optimally.
Now another thing you might want to try is, do you have a metal core? As you're doing the experiment, put your core slowly into the center of it and see, by creating more inductance in the coil, will your gains go higher. There might be a sweet spot where you can drop that metal core down to a certain point, and it'll give you a maximum output.
We were just thinking
just enough.
Yeah, we were just thinking that the other night when we were doing, I had some friends over running some experiments, and my friend mentioned that like we should have like a stable platform that we can measure the distance from the vortex to determine the optimal height. And that will be ideal for a rotary motor, because if you're only outputting one, regardless if the North Pole actually exists somewhere, if you're only outputting one pole that's really affecting the system, that's ideal for driving a magnetic motor.
Yeah.
And something that actually happened to me that scared the shit out of me was those little disc magnets. I had a stack of them, and I had them in the cup, and I was slowly increasing the frequency 1 hertz at a time, and I noticed it was, it wasn't jumping around, it was just vibrating, and then it just started making a noise.
That's good. That's good.
Yeah,
you're hitting a harmonic.
Is that the harmonic for the magnet?
Well, the actual field.
For the
field itself. Yeah, the field itself. Yeah.
So what happened though, and I can't explain this, and maybe somebody knows what happened, but I took one disc off of the stack. I had the stack in my hand. I put the one disc in the cup, and it didn't do anything. So I took it out, and I got it too close, and it snapped back, and it made a bright yellow flash. Like a small one, but right on the contact point where the two magnets met, it made like a small bright yellow flash. I can't explain what the fuck happened.
No. Magnets will do that. If they hit each other really hard, you will create an arc.
So it was holding a magnet, or it was holding an electric charge?
Well,
that's it's iron.
No, if you got two neodymium magnets and they hit each other really hard, they'll create a spark and break. They can,
they will break.
Yeah.
So I mean, they've snapped together before and not made a flash. Maybe the coil had something to do with that.
Could be. All I know is neodymiums are pretty well known for that. If they hit each other hard enough, with enough force, they will create a spark.
That scared the crap out of me.
Yeah.
Don't
Yeah.
put your fingers between them because
Yeah,
you're gonna
don't. Yeah,
crush them.
yeah, that's gonna hurt.
Yeah. Yeah, no, definitely. So that being said, there's a lot of weird stuff going on with this coil, and I'm really
Yeah, I
excited.
just all I say is try to increase the inductance of that coil. Try with the core,
Mhm.
putting it in slowly, and don't be afraid to go with higher voltage. Try to go higher voltage.
Yeah, when I get a more safe setup, I'll definitely do that. Right now, it's not exactly.
You can do higher voltage safely through a coil that has higher impedance, higher resistance, so a thinner gauge.
Yeah,
And then
yeah,
you
you'll
can
go
step
higher.
up the
Yeah, but I
I
don't
do
think
have
it
a
wants.
workbench power supply that can supply enough power.
Yeah,
Oh, no. I mean the voltage, not power. The voltage. You're not sending amps. You're just sending voltage into it.
Well, you can control the voltage with it too, but I mean, it can send a lot more voltage than my stereo receiver can.
If the coil has a higher resistance, it won't allow the amps, but it will allow the voltage.
Yeah, no. So you're saying the amps will kind of stay at the same current flow?
A higher resistive coil will allow you put like let's say 100 volts through a high resistance coil, and you got like a 100 amp battery behind that 100 volts. Well, so like the coil, let's say the coil is a 500 ohm coil. 500 divided by volts divided by resistance. So 100 volts divided by 500 gives you 0.2, which is 200 milliamp. No, is that 200 milliamps?
yeah, 200 milliamps.
200 milliamps. So how are you going to burn something with 200 milliamps?
Yeah, the only time I would start worrying is if you go over
But
an amp.
the voltage got through. But with that voltage, it was only that's because of the resistance the coil had. You see, so
That makes sense, though. That does make sense. And the way that I kind of confirmed that it was actually accurate is because my multimeter is brand new, but it's only rated to 250 milliamps, right? So, and it was at 260.
right.
So
yeah,
I know it was
go over that, you'll
calculating
burn
that
it.
amount of current.
Yeah, so using a thinner gauge winding is not going to, you can step up the voltage safely, no problem.
Okay. Yeah, maybe the next frame that I wind will be a thinner wire.
The power supply doesn't need to be a high amp power supply, but it needs to have a high voltage. Like you could use a low amp rated variac and put a diode on it to get your high voltage.
Let's see a little more, Gerald.
Yeah, no, my power supply I think is rated for 50 volts.
50 volts.
But
only 200
it's not going to
milliamps.
shut off if it's not going to shut off if more than that, or it's not going to shut off if 50 volts come back into it, but the receiver does.
You mean from the flyback?
Right, exactly. Yeah, the receiver is shutting down after a certain power.
Well, you can shunt the flyback. You can shunt the flyback to a battery, capture it into a battery so it doesn't hit your power supply at all.
No, that's smart. Yeah, I could do that. I could look up that.
That's the Bedini SG.
You said use resistors on the back channel.
Well, you could even put
diode.
You could put a diode, or you know what? You could get an LED light, hook up the back spike right to that, and it'll just dump into the light so it doesn't hit your power
LED
supply
also,
and blow it. Well, LED might be a little small. You could go LED. Because that's what I dumped my circuit into is a regular household LED. Yeah.
How many times did you wind that one?
Oh, Gerald.
Well, Gerald. That was 750 feet one way and 750 feet the other way. Bifilar.
Yeah, that's a big one.
Yeah,
yeah, I spent some time on that.
Yeah.
22 on the primary, 23 on the secondary, or maybe reverse that. I'd have to look at my notes. It's been a while.
That's a lot of beef.
Yeah, it does some really crazy stuff. I could get, depending on my circuit, can pull 2100 volts out of the secondary with like 24 volts input on the primary. It's insane. It's dangerous.
Yeah, that's crazy.
Yeah.
That is crazy.
I'm gonna do all those demos very shortly. My life, I don't have funding. This is all from, like, this copper here for this coil came out of the back of old tube TVs.
Hey, I understand, man. I'm out of an apartment right now. I'm doing these experiments.
Yeah, so it's like I do what I can when I can, right? So I work a job, I do renovations, get up enough
real
money,
science.
buy stuff, do experiments. So,
that's how you know it's real if
people,
it's not funded by others, right? My God.
Right.
20 gauge, right, Joe? 20 gauge.
But most people, they'll work their entire day and then come home and be tired. But us, we push it. We just constantly push it because we're trying to actually use our limited free time for this stuff, and it's very time consuming.
It is. Just in case anyone's wondering, that's the ohms on that.
Is that considered pretty good for that size?
That's like a 16 or 18 gauge. Right?
No, it's not 18. It's got to be 20 or 22 or 23. Those are the only gauges I was working with back then.
Was that 2 pounds?
And, maybe 2.5, give or take, without the ferrite cores.
Right. At that gauge, you'd get that kind of ohms.
So what do those cores do around the outside?
They pick up voltage on the outside and they light these LEDs. These LEDs that are on them are in series.
They're picking the flyback.
Oh, they're pickup coils. Okay.
Yeah, they're picking
the flyback, right?
So listen to this. According to some of the videos that I've been watching regarding First Stop Energy's tutorials and demos, they actually have their main coil and their smaller coil. You can put it on top and it'll transmit wirelessly the electricity. If you put it just by setting it on top of the other coil without any power going into the secondary coil. And if you spin a magnetic motor above the primary driving coil, depending on what number of winds you have on the secondary coil, you can set it on top and it will deaccelerate or accelerate the spinning of the magnetic motor.
Yep, absolutely. That actually, I have the same effect. A little different than what yours is because I understand.
Yeah, anyone who's messed around in the lab has seen how energy transfers itself and never loses itself.
Right, and the closer you get to that path, the more you'll see these weird things happen.
Yep. Like I can light all these LEDs and pull like 16 volts out of every full wave bridge rectifier after putting 12 volts into the primary.
Yeah,
but my secondary. Yeah, but my secondary will have a super fast diode with a small capacitor bank attached to it.
See, even that, with disregarding the current, even transforming the voltage like that with a 1-to-1 ratio coil is supposed to be impossible, right?
Supposed to be, but this is based on geometrical form. I don't see here.
Well, no, it's a 1-to-1 ratio of turns, but not the same gauge, and that means the resistance is different, and the flow rate of current through the two of them is also different.
Oh, so there's two different gauge wires.
You got to keep that in mind. The resistance difference in resistance means difference in pressure valves, the pressure chamber difference.
Yeah, but that has nothing to. I agree with you, Mike, but you're talking. It's so minute that.
No, it's not. It's a very important factor here.
Yeah, but it can't account for the anomalies I'm seeing.
Yeah, well, when you have two windings that are the same gauge, same resistance, symmetric, then they cancel. Even if you wind them the opposite direction, they cancel.
Yeah, but
because
I believe you're correct when it comes to solenoid coils.
No, they don't cancel. They simulate a cancellation. But what you're seeing is just one signal, not two, because it's two identical signals. But you're only going to see one.
It's actually the same signal that's inversed.
If you can invert it, right? But will you see it with your meter? No, because your meter is not designed to read that.
But I do see it though, Mike. That's what I mean. There's a way of seeing it. I've been playing with this for 12 years, dude. I know about this
There's a way
stuff
of seeing it.
in my sleep. I'm telling you. I just haven't released everything that I know because it's
But
very
having two
difficult.
different flow rates.
There's a lot of naysayers.
Yeah,
out
you
there.
talk about this shit with everyday people, and they think you're crazy. Half.
Yeah, and if there's an electrician or
They
an
don't
electrician
understand
in
pressure and
the room,
voltage.
forget it, because he's got this thing stuck up his ass about the
Right.
3 law of thermodynamics.
Thermodynamics,
drop.
yeah. You can't break the
The
law of
second
thermodynamics.
law of
It's different.
thermodynamics does
Well, until
not
we unite
apply.
the gravity with the other fundamental forces of nature, I think we're missing a key concept here.
Well, but see, but that's the thing when you're talking about.
Well, you're
Einstein,
creating eddy currents with 2 flow rates. I mean, that's the important thing to understand here. Those eddy currents are what is going to give you the excess.
Oh,
So
it's
what
so
is-
much
what
more
is
than
an
that,
eddy
Mike.
current? Could
So
you
much more.
can you
Well, an eddy current is when you have two different flow rates at
It's so
different
much,
pressures.
Mike.
That creates eddy
Skin
current.
effect comes into effect. The dichotron instability comes into effect. There's
Skin
so
effect
many
is the eddy
different
current.
things.
It's the same term. It's the same thing. Skin effect and eddy
So it's like a
currents is-
pressure
It's
differential.
not actually.
The eddy currents are happening on the skin of the wire. That's what happens.
Yes. Not in the
Oh, okay.
wire.
It's the same thing.
Hmm.
It's the same thing.
Not
It's
quite.
very
That's where
impressive.
your head's at.
I like that
Are you an
setup. I want to
electrician,
try to
Mike?
do some pickup.
It's not the
shots.
skin. It's the skin of 2 wires that are wrapped around each other, and
Mike.
the flow is
Yeah.
in 2 different directions, and they're in
You're
2
great.
different
You're my
pressures.
friend, but I got to ask you something. Are you an electrician?
Yes, sir.
Okay. That's all I need. No, brother.
Breaker, the other one's a 50 amp breaker. It's kind of look at it like that, you know. You can allow 2 different
Nothing
flows.
like that. Nothing like that at all. What you're talking about are linear forms of copper. This is non-linear. This creates spin.
Yeah.
It's a totally different dynamic. Totally.
So
Well, that's what eddy. That's what eddy
I
current
made
is.
this one,
It's
and it
spin.
doesn't. Just to compare it, it doesn't produce the same effects, obviously, but it's like my control.
Oh yeah, yeah, I get that. Here, I'll get.
Yeah,
off
so it's
the-
just a regular coil. It doesn't really do anything compared to these coils.
Right. You're inducing a high rate of eddy current formation, you know, through that method.
But I will say that color coordinating the coil leads did help me out quite a bit when trying to hook it up, because it can get kind of confusing.
Opposite
Yeah, the POE.
rotating magnetic fields, opposing.
The POE is difficult to wire.
It is.
I made one once. Yeah.
It's a little bit of a process, but I mean, I think I've learned a couple of tricks that I can, teach everybody, and hopefully you all can make one, and we can all have these
Absolutely.
results
I've
or
been wanting
verify
to
or
for a
refute them.
while.
Like that's what I'm looking for.
And like it's a 3-phase,
You
correct?
said what?
It's 3-phase the POE.
It's a bifilar, 2
Or like
wires.
3.
Yeah,
wiring?
it's 2 channels.
2.
not
Only
3.
2. Okay.
No, so it's 2
Three.
channels. So it's
I thought
got
they did
it's
a
got
3
20.
channel one.
It's got a bundle of
No, it's a
20
single.
wires.
It's 2 wires in series, so it's like a 2-phase, but they're wrapped around each other. So it's like 1 phase with 2
What's the
directions.
POE full?
Yeah, it's really weird. So it's a bundle of 24 wires, and then you're taking 12 of those wires and putting them in series for channel A, and then the other 12 in series for channel B.
The best way to describe it is you're
Okay.
sending current from left to right clockwise, and then right to left counterclockwise through the same wires, 2 wires that are in series, and they're different in resistance. They're not symmetrical, or at least that's how I understand it.
I mean, it's
Or
really
they
hard
are.
to get them symmetrical if that's what you're looking for. But there
Are
are
you trying to
theories.
get it symmetrical?
No, there are theories that depending on how symmetrical the outputs are, the leads themselves, like having them different lengths could have different effect. So on the next coil, I do want to make the output leads the same length. Just to see
Well,
if
just
that,
changing, just
Sure.
having them the same length and having different gauges does not make them symmetrical. It makes them asymmetrical. They're not the same size or the same shape.
No, the same length.
Well, that doesn't make them symmetrical because they're not the same mass and they're not the same resistance and all of that.
Well, it might have some effect. At the very least, it'll keep.
Oh, I mean,
it
having
nice.
having symmetry is a way of canceling out your signal. Even you can put it 180 degrees out of phase. It's just like a way of taking noise and silencing it. Like
Well, it
the
makes
helicopters
sense
do.
that what you're saying, because now that I think about it, what you're doing is you're putting the wires in series and creating a big bump right
It's an
there.
inverted circuit. It's an inversion
and that,
circuit. Kind of.
yeah, and that doesn't really seem to affect the efficiency of all of the system.
Symmetry is a way of inverting. You know, you can create symmetry, but inverted symmetry, and then you cancel out a signal and all that. Or you're not really
Oh, it's
canceling
probably
it. You're just
more about
muting it.
it's probably more about the uniformity of the bundle itself. Then.
Yeah.
What I'm saying is the bifilar is 2 windings, but they're not the same thickness. They're 2 different cages, right?
No, but you want that system to be asymmetrical. You don't want it symmetrical.
Oh, okay. I didn't know that. Yeah, that's what I'm thinking. You want it to be asymmetrical for having the harmonic resonance take effect. Yeah.
No, maybe mine is asymmetrical. It is kind of bent.
What I'm saying is like you're sending a current with a certain amount of milliamps, which creates the note A, for instance, the musical note A, and then you double that. You give that milliamps, you multiply it by an octave, and you have the same A but at a higher pitch. Let's say you don't do that, and you just create a C, which is a resonance to the A. So the C is, let's say, that's 600 milliamps. So you got 200 milliamps going through the bifilar on the first winding, going from left to right, and you got 600 milliamps coming back the other way, going from right to left. That's a pressure differential. That's where I think this over unity is taking in that kind of a system. You know,
that could be. I mean, if you look at asymmetrical systems, though, they seem to be prominent in physics.
Yeah,
so they create a harmony or a melody.
Right.
It's all.
That's the only way you get over unity is an asymmetrical system. A symmetrical system will cancel itself out.
Right, symmetrical is like having a lower A and a higher A. That's symmetry.
That makes sense. So what you're saying is my system is probably asymmetrical in some way.
Even Tom Bearden.
Right.
Tom Bearden talked about this.
It has to be.
Has to be asymmetrical.
If you look at the Thane-Heinz device,
this gives a lot of new data to my research that I need to rethink things.
A lot of key points.
I was thinking it's all about the symmetry, but maybe it's the lack of symmetry.
Like even Bearden said too, is non-equilibrium. Is basically what he's saying. As long as your system is non-equilibrium, you'll get the over unity effect. As soon as you get
you have to break the symmetry.
Yeah,
that's what he says. You have to break the symmetry. Those are his words. Right. Break the symmetry. That's his.
Yeah, but he's talking about breaking the symmetry of the circuit, not the coil. The coil is a separate animal.
The coil is a part of the circuit.
So you're saying even if it's the same gauge size and length and all that, it could have different resistance.
Break the symmetry, but having not two notes of C, but a C and a D, which resonate with each other, which they're in harmony.
Right.
They're not symmetrical. They're 2 notes, but they're in harmony.
What I originally thought. I'm glad I came
breaking
on
the
here.
Symmetry doesn't mean
stoked to have you on, Ben.
Breaking the harmony.
A lot of good key points.
Oh, real quick, I forgot to tell you guys. The temperature only registered a degree higher. All that time we had it running. It was the ambient was 75, and it was running in the vortex on the coil wire at 76.
It's only a couple watts, so.
No, what
you got to reach over 1,000 watts to get hot. You know.
Well,
500 watts.
Well, if you're getting the real effect of 0 point, it should be cooling down.
Right once it starts taking in the radiant energy.
That's right. If it's taking in the radiant energy, your core should start.
That's what we should see. We should. That's what Daniel Nunes described in his center of his coil is a 10 degree reduction. So I might have inefficiencies in my coil in some way, but for some reason I'm still seeing an increased output. And I'd like everybody to try to replicate this to see if they can get the same thing.
Yeah, I think you're just running too low.
Too low.
Too low voltage.
When your coil starts to cool down, you have to give it the opposite reaction on the other side of the circuit. like sort of like breaking symmetry. So
You don't
I
have to
have to
rewind
show
it.
this. I have to show this crew this, but I did an experiment where I run my coil system. I believe it was at 880 hertz. I have a small capacitor bank on the back end of my transistor circuit. I'm running it in a negative bias. Then I run that through a 900 watt electric element, and I heat it to about half of its heat. But when I'm doing that, my coil cools down. And I mean like almost to the touch where you touch
It gets colder, like noticeably colder.
Yeah, it feels like it's burning your finger.
That's cold electricity, baby.
Right? So
what do you mean when you say you're running a negative bias? You're switching the negative?
You have to have a resistance somewhere in the circuit that sucks the heat while you're like as a load when you're running it. So
okay, that makes sense.
Something to think about.
Gerald, what do you mean when you say you're running in a negative bias? Does that mean you're switching the negative side on? What does that mean?
Okay, so the coil circuit that I got from Bedini, I
mean, like if you're running in a positive bias, what is that?
Yeah. So I run the negative. I go from the negative of the wall plug to my primary, and then from the negative part of my primary through my 2N0355. Does that make sense?
Oh,
So
okay. You're the transistor.
I'm trying to follow.
You're using a PNP, not an NPN.
Yep, I'm using a PNP. Yep.
Which is like switching the negative.
Absolutely. Yeah. It's all about how you play with the polarities, right?
You're using the negative potential to create your switches.
Exactly. And by doing so, I'm getting a mass amount of positive potential. See, all those little things, they add up. You can't do it with just a free energy circuit or a free energy coil.
For the people listening that don't get that, let me just explain. The positive potential is like taking a plus 5 volts from the battery and touching the base of a transistor to get it to close the gate. You're giving it a 5 volt positive potential. What he's doing is he's using not an NPN, he's using a PNP transistor, which can read, it senses negative voltage on the emitter, if I'm not mistaken, Gerald. Is that correct? And the positive is still hitting the base, the positive of that negative that you're giving the emitter.
Yeah,
it's still connected to the base of that same PNP.
Absolutely.
But it's getting triggered from the emitter side, not the base.
Yep.
Of the same transistor, the two types of transistors. That's interesting. Yeah. That's
because if you put a load on the positive side of that 2N355 and you run your coil on the negative side, your potential goes through the roof on your coil end.
I'm vaguely getting what you're describing right there.
And your system runs way more efficient.
It's like running a light bulb on the negative leg or something.
Exactly. But when I run it on the negative rail, I flip the polarity through my coil, turning it into a
positive. So what Gerald's describing here is he's pulling positive energy towards his negative potential device by creating it, giving it a negative potential through the ground, right? You said you had it connected to the ground.
Yeah, my secondary is connected to the ground.
And that's your negative potential. That's how you make the device having a lesser potential to the positive from your source.
And then all my pickup coils just scream with that positive potential that's flipped.
So instead of pushing the source energy into his device, he's pulling the source energy into his device from the opposite end of the circuit, not the source end of the circuit, from the other end of the circuit, which is the drain end of the circuit, right? The drain end?
Because think about this. Think about this. When electricity is flowing, when you flip on a light switch and you turn on that light bulb in your room, and you flip it off, that power goes back through the wall to source
The opposite direction. It goes to
faster.
the opposite.
Exactly, faster than it did when you turn the light on, because it
At a
has to
more
be
than
there for the
10x
next time you turn
multiple
the
in
light on.
voltage.
What's that?
And also at a more than 10x multiple in voltage.
Exactly. See,
But at the
and
same
that's
time,
where
a
you
10x decrease in amps.
see. You're getting it, Mike. That's
Not
exactly what I've
decrease,
been
but
doing for the
conversion.
last 12 years.
You switch voltage for amps every time you convert. You don't lose anything unless the circuit that it's being converted through has they're not in tune with the volts that you're putting through and all that in the amps. They have to be like the coil has to be rated for over. Let's say you got 5 amps pushing through a coil, and your coil can only handle 4 amps. That's not going to work out. You know, your coil has
No,
to at least
I
handle
can
more than
handle
5
more than
amps.
that.
And having a coil that only handles the 5 amps, which is what your source is putting in, and only handling the maximum is still not going to be good enough. You want a coil to handle 10 amps for a 5 amp source, and then you're not going to have any heat or any losses.
Well, when I was at my max, and I had to shut it down because it freaked me out a little bit. There was some anomalies I won't talk about right now, but when I was at my max, I was pulling 1800 watts through that coil. That coil at 20 gauge and 22 gauge, or 22 and 23. Like I said, I got to check my notes.
That's a pretty,
That's
that's
about
pretty
10
thin
amps.
gauge. Why to be doing that?
I know, because you know why? The coil does not heat up.
That's
I've
18 amps.
And you know,
never had it heat
I
up.
had a theory when
15
we were
15
saying
amps.
powering it off has a spike in voltage. I had a theory that that's maybe what John Searle's doing with his Searle effect generator, is pulsing it on and off.
Yeah,
But-
collecting the back spike.
The rollers are doing that.
Yeah.
So there you go. You guys got 2 secret sauce secrets tonight.
Right? Huge
I'm
secret
just-
sauces.
I
Oh,
wanna
this has
give it
been a
up.
great. This has been a great
Learning
episode.
100%.
Absolutely.
One of the best.
Yeah, we got.
By the
we got
way,
about, we got about 5 minutes, and then we'll square it up. All right.
Sounds good.
by the way, if you want to boost up your voltage, with the same power supply and give it the full 50 volts, just put like a 10 watt, 10,000 ohm resistor on the positive side of your power supply, coming out to your coil, and you can turn up the voltage without sending any more amps.
Oh,
Yeah.
so the positive end of the output channel.
Right, or the
Okay.
negative, but I don't know which will work better. It's kind of
I can do that right now. I mean, I know we don't have time, but I'll do it for the next show.
Yeah.
Totally.
Absolutely.
you can try either the
'cause you're
positive
using
or the
the
negative
stereo
or both even. You can put
But
you
no,
can put a
this
resistor on both the positive and the negative.
This is
Like a
real
five
This
science.
is just everything about this coil just blows my mind.
I think
Make sure
you'll
those
find-
resistors can handle at least five or more than what your power supply puts out in watts.
Yeah,
Oh, yeah.
yeah, no, I agree, Mike, totally. Because they will
They'll
heat
just
up.
get hot and burn up.
I've gone through a few of them already.
Yeah,
Yeah. The high wattage ones, they cost like $1 more, but they'll never burn out on you, and they'll keep using them.
Yeah, the ones
but
that come
like-
with my Arduino kit aren't probably gonna cut it.
the white ceramic ones that come out of the back of old tube TVs, they're like 10, 15 watts. Those are the best, but they heat up.
Yeah, those are the best ones. Yeah.
Well, I got a
Yeah,
HV
by far.
capacitor that's 2,000 volt rated. Maybe one of you guys can show me how to hook it up to the system one day.
Maybe
Absolutely.
next week.
Well,
Right?
where are you
Same
located?
place, same time. Ben, where are you?
Where are you located?